So, good morning, everybody. My name is Shreya Bhadoria, and today's our topic in data structure is minimum cost spanning tree. In this, there are two types: Kruskal algorithm and Prim's algorithm. In Kruskal algorithm, no source node is fixed, means no source node is required. But in case of Prim's algorithm, we have to choose a source node for defining minimum cost. Let's see what's the topic inside. This is a question: is B, C, D, E, F, and G, and we have to define for Kruskal algorithm. So the process, which includes identify all the vertex and edges here. Step second is take those edges whose cost is less, minimum cost is there, take only those edges and cover all the vertex without performing cycle, means loop should not be created. Okay, and step third is make figure from selected edges, the minimum edges, minimum cost edges which you have selected, take that edges and calculate the minimum cost from them. So for solving the question, we are from here, like edges, vertex are there. From there we can see vertex A, B, C, D, E, F, G. 7 vertex are there. And edges AB 4, AC 8. From figure you can find out these edges simply. And here step second, make a rough diagram like that. Only points should be mentioned: A, B, C, D, E, F, G. And so we come to the step second, like I have told you the minimum cost age. So find out the age who have minimum cost. In this we can see CF1, minimum cost is 1. So in that figure we use CF, minimum cost is 1. CF, minimum cost is 1. We draw like that. And after 1, FG having 2. So F and G having 2. F and G having 2. After that, CD has also 2. So we use CD 2. After that we can see 4 is there. So here we use AB4. Okay, like that. 8 is also used. Why we can't use 6? As we see EG, look in figure, if we use EG is equal to 6, the cycle will perform like that. That's why we are not using EG is equal to 6. And like that DE also is not used, DE, because a cycle will perform. That's why we are not using DE and EG. Even although it has a minimum cost, then also we are not using EG and DE because it will perform cycle. So like that we conclude the figure, and then we come to the cost. 1 plus 2 plus 2 plus 4 plus 5 plus 8, 22 will be there. So we conclude our figure up to that, and we find the minimum cost here. As same, there is also the Prim's algorithm. We can see Prim's algorithm. So step number first for Prim's algorithm is consider a source vertex. Here in this, source vertex is mandatory. So consider a source vertex, and step second is calculate minimum cost of adjacent edges and add the adjacent vertex with minimum cost to the source vertex set. Like in this figure we can assume a source vertex. Assume the source vertex to be a A. Here we assume A. So the adjacent edges of A are A, B and AC. Adjacent edges are these, but we have to take the minimum. So we take the AB side, that is 4, and then B will also come there. Okay, this is written here: calculate minimum cost of adjacent edges. Minimum cost of adjacent edges is AB4, and add the adjacent vertex with minimum cost. And we have to add the adjacent vertex with the minimum cost, means A and B. 2 will become there, A and B. So repeat above step for all vertex in source vertex set and check minimum cost. After reviewing all these, we have to take in consideration the minimum cost of that. Like see that problem is there. Vertices A, B, C, D, E, F, G. Vertices is 7 and ages is final. Ages, formula of ages is B minus 1, means 7 minus 1, 6. In final figure, ages will be 6. So we take a source code as A and then minimum cost AB. AB is there and AC is there, adjacent vertex. So we take AB as 4, AV is 4, then we add that vertex also in this. So AB whole is there. So from A we find that AC having 8, BC having 9 and BD having 8, BE having 10. So the minimum cost is AC 8. After having A, B, C, we find a new node, that is C. A, B, C. So B and C having 9, B and D having 8, B and E having 10, C and F having 1, C and D having 2. So we take C and F having 1, which have minimum cost. Like that we go here, A, B, C and F, then CD 2, CD will be 2 and FG will be 2, CD will be 2 and FG will be 2. So 2 and 2 are there. By these we make a figure like that. This is the figure. Then we conclude the cost 1 plus 2 plus 2 plus 4 plus 5 plus 8, that is 22. This is the Prim's algorithm, and the first one is that is Kruskal algorithm. Thank you.